Welcome to Pindar Poetry. We hope you learned something new.
You start by locking in hardware and software choices so you can build reliably. First, pick a compute platform like Raspberry Pi 4 or Jetson Nano for neural workloads. Next, wire a basic power rail, 12V battery to a 5V regulator for the compute board, include a 10A fuse. Then mount primary sensors, a 1080p camera and LiDAR DAR or ultrasonic pair, and an IMU for orientation. Once done, verify device boots and that you can SSH into the board. Now you integrate sensors and build the software backbone so components talk smoothly. Install a supported OS, then layer ROS2 for interprocess messaging. That simplifies sensor nodes and control loops. Add OpenCV and TensorRT for efficient vision inference. This accelerates object detection on 1080p streams. Calibrate the IMU and synchronize camera timestamps with the LiDAR to avoid drift, and run sensor fusion so your localization is robust. Finish by refining control and safety so your smart car is reliable in real conditions. Deploy PID steering and velocity controllers, then tune gains with brief, incremental runs to prevent overshoot. Add a hardware e-stop and a software watchdog, plus battery voltage monitoring and rolling logs so you can trace faults. Validate behaviors in obstacle avoidance and lane keeping tests, and run low-light camera checks. If sensors drift or control oscillates, recalibrate IMU, retime-sync sensors, and reduce controller gain as the key troubleshooting step.
Thanks for watching. Consider subscribing if we helped you.